Hello friends, I came across an interesting question about right triangles from the Indian Regional Math Olympiad of year 2013. Let's take a look at it. The question is, let ABC be a triangle with angle A equal to 90 degrees and AB equal to AC. Let D and E be points on the segment BC such that BD is to DE is to EC is equal to 3 is to 5 is to 4. Prove that angle DAE is 45 degrees. To solve this question, let's construct a diagram that represents this question. We will construct a triangle ABC, which is a right triangle with the right angle at A. It will also be an isosceles triangle with AB equal to AC. Let's mark 2 points D and E on BC such that BC is broken into 3 sections in the ratio 3 is to 5 is to 4. Let's label these sides 3, 5 and 4. Remember that these numbers are not the actual lengths of those segments. The actual lengths are actually not important here because the diagram can be scaled up or down while maintaining the ratio 3 is to 5 is to 4. For the sake of better understanding, let's assume that the lengths of the segments are actually 3, 5 and 4. We can also solve the question assuming that the lengths are 6, 10 and 8, which are also in the ratio 3 is to 5 is to 4. But for now, let's assume them to be 3, 5 and 4. Then the total length of BC is 3 plus 5 plus 4, which is 12. Now let us connect A to D and E. We need to prove that the measure of angle DAE is 45 degrees. Let's start by marking the angles whose measures we know. As ABC is an isosceles triangle with vertex at A, so angle B is equal to angle C. And as angle A is a right angle B plus angle C is also 90 degrees. So angle B and angle C are both 45 degrees. Now let us drop a perpendicular from A to BC and let's label the point of intersection here as P. Remember that for an isosceles right triangle, P would be the midpoint of the hypotenuse. This is because triangle APB and triangle APC will be congruent by ASA postulate. I will leave this for you to prove as I expect this to be straightforward to show. This tells us that BP is equal to CP, and because BC is 12, so BP is equal to CP is equal to 12 over 2, which is 6. We can also see that triangles APB and APC are isosceles right triangles. This is because both triangles contain a 90 and a 45 degree angle. So the third angle in both triangles is also 45 degrees. Hence, both these triangles are isosceles. So AP is equal to BP is equal to CP is equal to 6. Now we can also calculate DP as BP minus BD and EP as CP minus CE. So BP is 6 minus 3, which is 3, and EP is 6 minus 4, that is 2. Next, we will apply the Pythagoras theorem to triangles APD and APE. So AD square is AP square plus PD square, which is 36 plus 9, which is 45. So AD is square root of 45, which is 3 square root 5. Similarly, in triangle APE, AE square is equal to AP square plus PE square, which is 36 plus 4, which is 40. So AE is square root of 40, which is 2 square root 10. Now if we observe triangle ADE, we know all the sides of this triangle. AD is 3 root 5, AE is 2 root 10, and DE is 5. So we can apply the cosine rule to find the cosine of angle DAE. Cosine of angle DAE is AD square plus AE square minus DE square whole upon 2 times AD times AE, which is 45 plus 40 minus 25 over 2 times square root 45 times square root 40. So the cosine of angle DAE comes out to be square root of 1 over 2, which is 1 over square root 2. And so the angle DAE is the cosine inverse of 1 over square root 2, which is 45 degrees. This proves that the angle DAE is 45 degrees. I hope this solution was useful for you and also fun to watch. Please like this video and subscribe to Concept Shala's channel for more such interesting videos. You can also comment and let us know if you have a question that you'd like me to solve on this channel. Thanks again.